ನೋಡಿ ಸ್ನೇಹಿತರ, ನಾವಿರೋದು ವಿಶ್ವೇಶ್ವರಯ್ಯ ಮ್ಯೂಸಿಯಂ ಅಲ್ಲಿ. ನಮ್ಮ ಗುರು ನಮ್ಮ ವಿಶ್ವೇಶ್ವರಯ್ಯ ಭಾರತ ರತ್ನ, ಭಾರತ ರತ್ನ ಸರ್ ಎಂ ವಿಶ್ವೇಶ್ವರಯ್ಯ, born 15/9/1861, expired 14/4/1962. ಸೊ ಇನ್ನೊಂದು ವಿಡಿಯೋಗೆ ನಿಮಗೆಲ್ಲ ಸುಸ್ವಾಗತ ಸ್ನೇಹಿತರೆ. ನಾವೀಗ ಇನ್ನು ಹೋಗ್ತಾ ಇರೋದು ಬೆಳಗಡೆ. Process to start airflow. Lift the disc towards air outlet. Not that it is difficult to move this against the airflow, but when the disc is close to the air outlet, it is sucked outlet and floats without any support. The force of the air get on the disc makes it tough to move up. The disc is close to the air outlet. Air flows rapidly outwards through a narrow gap, as in the picture. The high speed of air is this gap creates a low pressure area and balances the force of jet. Thus, disc floats. Place the square wheel at one end of the bumpy road. Give the wheel a push and watch it roll smoothly. Notice that the center of the wheel stays at a constant height as it rolls. The circular wheel rolls smoothly on the flat ground because its center is always center of the wheel stays at a constant height as it rolls. The circular wheel rolls smoothly on flat ground because its center is always at the same height. If you try to roll a square wheel on the flat ground, its center will move up and down. Extra force is required to make this happen, which is why the square wheels don't keep rolling in their own. The bumps in this road are in the shape of centenary curve. The square wheels rolls on these bumps because the bumps keeps center of the square at the same height. Through the switch, bring the airflow into the airflow. Notice the ball in the tube connected to the airflow moves up. Repeat the different angles at which the air strikes by gently moving the airflow. The ball moves up because of upward force acting on it. Air flows faster over aerofoil due to its curved shape and the angle at which air strikes the airflow. Fast moving air creates lower pressure on the upper surface. This is major factor contributing to the aerodynamic lift that enables aeroplanes to lift off and float in air. Aerofoils develop maximum lift with maximum maximum lift with minimum resistance. Hence, aeroplane wings are made in aerofoil shape. Bangalore principle. Press switch and direct the jet of air between the two heavy spheres. Observe that the spheres come closer. In fluid flow, high speed is associated with a low pressure. Hence, pressure is comparatively lesser in the jet of air than the surrounding air. In other words, there is an area of low pressure between the spheres. So, surrounding air, which is at a higher pressure, pushes the sphere towards the jet, thus bringing them together. Rotating table. The center portion of the table is rotating freely. Roll the objects starting from the sides to the central portions. You will find the motion very unusual. Can you predict the motion of the objects at different parts on the rotating table? Objects in a rotational frame of the reference behave differently compared to interior frame of reference. Which we are all familiar. First switch, the icon is cut along different planes. Observe the shape of the curves formed at the cut sections. These curves generated by cutting a cone along with various planes are known as conic sections. Circular ellipse, parabola, hyperbola are conic sections. We get the circle by cutting along a plane parallel to the base of the cone. Cutting along a plane parallel to the edge of the cone gives parabola, ellipse and hyperbola are obtained by cutting along appropriate planes. It is possible for a straight rod to pass through a curved path. Press the switch. Observe. We are rotating a stick, generating a three-dimensional surface which is hyperboloid. The curved heel slits through which the stick passes in the form of hyperbola. This form is obtained by interactions of hyperboloid with a plane transparent surface at the middle. Handle spring shape press of the rods. 3 diamond shape press of retaining rod is called hyperboloid. Can you predict what shape will be formed of the liquid when you spin the crank? Now rotate the handle to spin the crank. Your guess is correct. The surface of the spinning liquid makes the shape of a curve or parabola. The part of a ball thrown in the air is a parabola. Headlamps, parabola shape reflectors are used. Strike the drum through a part of the ball. Well, the drum has to flutter another part of moral. When you strike the drum, the flexible membrane pushes the air inside. The narrow opening on the other side is not sufficient for air escape instantly. This causes a portion of the air to get compressed inside the drum, which subsequently escapes the sudden burst of air. This puff of air is actually a vortex generated by cross-moving air, and it can travel across large distances. Bring your hand above the polished dish. Can you locate the hot spot by moving your hand between the bulb and the dish? You feel hot at one point. It's about 30 centimeters above the dish. The dish is in the shape of parabola. The heat generated by the bulb at the top is reflected and concentrated at the point called the focus of the parabola. It is the focus that you feel the maximum heat. Solar collectors are made in this shape to concentrate solar energy. Gravity, roll the ball barrel to the outer edge of the dish. Notice that the ball goes around the dish in a circular path. Also notice that a complete orbit takes less time as the ball gets closer to the center. Now roll the ball slightly in the outwards. The center of the dish is the shape of its path, the same as before. Try rolling the ball at different speeds. The ball acts much like planets obtaining around the sun. just as balls move in nearly circular paths around the whole. Planets also have nearly circular orbits around the sun. The further a ball is from the hole, the more time it takes to complete one orbit. Similarly, further a planet is from the sun, more time it takes to complete one revolution. Whispering this, they whisper from here, you can hear it from here. Tornado forms severe thunderstorms when updrafts of warm, humid air starts to rotate. Here an overhead fan draws the air upwards, imitating cold draft or propels core of tornado. Air entering from the side makes the updrafts spinning, creating what is called an air vortex. A small scale tornado vortex is one of the many types of vortices that occurs in the atmosphere. Hurricanes, frontal rainstorm, water sports, dust holes are other examples of atmospheric vortices. Each pendulum swings at a rate depending on its length. The longest pendulum swings 15 minutes and 30 seconds. The next longest swings 16 times in 30 seconds, and so on. The smallest pendulum swings 25 times in 30 seconds. Since all the pendulums complete an exact number of swings in 30 seconds, they come back together after 30 seconds. In between, they make the interesting patterns. Rising bubbles. Press the lever and observe the rising bubbles inside the liquid column. Watch the bubbles grow in size by they move up. As bubbles rise up, pressure exerted on bubbles on all the sides while the surrounding liquid increases. Pressure varies directly depth in the liquid column. As well as bubbles size and grows size. The rising bubbles behaves differently with different densities and viscosities. Turn the handle to control the air flow. Observe while the fan spins and moves up. Reduce the air flow and watch the thickness of the fan. Then make it flow and height. Flow of the air from spinning results in electric force along the axis of the fan. The fan moves up, more air flow, more will be the lift. It will control the spin such that the lift force balances the weight of the wing. You can make it float in any positions. The rotor of the helicopter provides lift in a similar way. This is the resonant frequency of that wing. Plus the other two switches on the floor. Every object is one natural frequency of vibration. If you vibrate a ring at its own natural frequency of it starts running. The ring is look through the opening, see your back on the mirror. For mirrors are arranged as in the figure. You cannot see the image of your face because the front mirror is at angle of perpendicular. Not your back gets reflected on the four mirrors as shown in the figure, and you can see the image of your back on the front mirror. shake hands with you. The mirror creates an image of your hand that looks real enough to touch. The color of the mirror makes the reflected light rays come mirror to form the mirror you see. Look at the rotating rings. They appear to be rolling over each other. Press the switch to stop the rays and what do you see now? Use the optical illusion, your eyes convince the axis of position of one ring with respect to the other. As the rings are at the angle with each other and as the joints are also rotated, the rings appear to be rolling on each other. Observe the beautiful patterns generated by a fan trickling down the swinging funnel. The funnel is suspended in such a way that it is located to two simultaneous simple harmonic which are at the right angles. The resultant part of the funnel is placed to the ladder of the series figure. Vibrating the strings, crack the strings and listen. Sing the drum and observe bass. The strings are not visually visible due to a high speed of vibration. The movie comes with the white and black lines helps us to see these waves as the string is not visible against the black background. This passing a white line displays only a segment of string. Next passing a white line shows same segments instantly. Since the string has moved slightly sideways, by the time persisting shows as a solid wave pattern and white lines can operate the lever to create a displacement at the lower end of the wave machines and observe that it generates wave that moves to the top. Also see that four moving waves get reflected and reaching the top. Turn the wheel to rotate the sphere. Tiny particles in the liquid make the flow pattern visible. Observe the swirling swarm like patterns formed in the liquids inside the sphere. Repeat rotating at different speeds. When you rotate the sphere, the fluid inside remains stationary and first eventually frictional forces between the inner surface of the sphere and the fluid starts. Speed of the fluid varies with its depth and distance from the inner surface of the sphere under some conditions. The fluid flow shifts from the minor up to turbulent. Often the boundary between the regions of inner turbulent flows shows large swell fluids. Atmosphere of other planets. Tools is to start the pump. So the water is discharged through all 4 jets. Now gently turn the knob to rotate the jet. What we expect is that water jet lags behind the tube. But what to do? What do you see? Water coming out through the straight jets bent backwards, while water from the bent tubes turns forward. That means water lags only in the case of straight pipes, and surprisingly it leads in the case of tubes bent towards the center. Water leaves each of the spinning tubes traveling sideways, pushed by the moving tube. But in the case of the bent tube, the outer end of the tube moves faster than the closing part of the tube. This means that the water streaming inward from the long tube is traveling sideways faster than the inner part of the tube. With the excess of sideways speed, the water stream varies head of the tube as it moves inward.
button. You will press the button. Gotla high paletas.
cause pattern like falling magnets. Notice that the magnets fall slowly and are evenly spaced apart, speed by spinning the wrist at different speeds. Objects normally speed up as they fall down, but these magnets fall at a slow, constant speed because of the upward push due to eddy currents. Eddy currents are short-circuited currents formed on a conductor due to moving magnetic field. The nature of eddy current is such that it opposes the very fast of its rotation. This prevents the magnets from speeding up. The magnets stay evenly spaced because they repel one another. Magnetic forces, gravity and eddy currents interact, moving the magnet in complex paths.
ಅದು ಹೋಗ್ತಾರೆ ಸರ್ ಬರ್ತೇನೆ ಪಲ್ಯ ಬೇಕಲ್ಲ ಹಿಂಗೆಲ್ಲ ಬರುತ್ತೆ ನೀಟಾಗುತ್ತೆ
This image shows the locus of point moving along the radial arm of a rotating frame. Press the switch to observe how the steel ball detects the locus of moving point with respect to changing parameters of polar coordinate system. Pull the string gently above the beautiful pattern formed by the image mirror. Two mirrors, when kept at an angle, produce multiple images. Here, four mirrors are so arranged that the images from interesting patterns. Color shadows. Red plus green, blue, red plus green plus blue, white, red plus green, yellow, red plus blue, magenta, red plus green plus blue, cyan. Stand in front of the screen. Watch your shadow in colors. Your shadow is cast by lights of three primary colors, red, green and blue. You get shadow in cyan, where your body blocks the red light because your green and blue light mixed together to give cyan. Similarly, you get a shadow in magenta, where your body blocks the green light, and a shadow is in yellow, where your body blocks the blue light. The rest of the screen is white. where all three primary colors are mixed. ball bearing. frictional losses. Ball bearings are usually found in light precision machinery, where high speeds are maintained, frictions being reduced by the rolling action of the harder steel balls. The balls are caged in angular grooved tracks called rails, and bearings are held in place by a frame commonly called as pillow blocks or plumber block. Plain bearing bushing. A common plain bearings design utilizes a hardened and polished steel shaft and a softer bronze bushing. The bushing are replaced whenever it has worn out too much. What to do? Rotate both flywheels simultaneously. You observe the flywheel 2 stops earlier than flywheel 1. So what is going on? Flywheel 1 uses ball bearing, whereas flywheel 2 uses plain bearing. In plain bearing, the surfaces are in sliding contact, whereas the ball bearing, the surfaces are in rolling contact. The rolling frictions being always less than sliding friction. This wheel mounted with the ball bearings rotate more freely and for longer time. Losses in electric circuits. Small amount of electrical potential is lost in wires. Most of the electrical potential losses occur within the electric bulbs. Electrical current. The flow of a charge has short friction associated with it, which is called a resistance. In an electric circuit with several electrical devices, there may be multiple stepwise losses of electric potential as the charge traverses circuits. As depicted in the diagram below, a charge carrier traversing the external circuit from A to H passes through 3 different light bulbs. Each light bulbs result in losses of electric potential for charge. This loss is in electric potential corresponds to a loss of energy in electrical energy is transformed by light bulb into light energy and thermal energy. Press switch here and observe the lamp glows bright. Press switch B and notice that leakage path and observe that the lamp glows dim. What's going on? Initially the lamp glows due to leakage losses in transmission line. The lamp glows dim. What is happening? Hosted experiment. What to do? Press switch A and observe the deflection of a magnetic needle. Press switch B and observe the deflection of magnetic needle in reverse direction. What is happening? In 1819, Hans Christian Ørsted, 1777-1851 had shown the magnetism had been produced by electric current, and this phenomenon is known as electromagnetism. He observed that pivoted magnetic needles is deflected when it is in the neighborhood of a wire carrying current. This is due to a field produced by the wire carrying current, which interacts with the field of compass needle. When the current is reversed in the wire, the deflection of the needle is reversed. Peter Barlow, 1776-1862. Peter Barlow was English mathematician and physicist. He devised an apparatus known as the Barlow's wheel. In 1823, the apparatus has a star-shaped metal wheel which is free to rotate on an axle within the magnetic field of a horseshoe magnet. Current flowing from a battery through the wheel set up a magnetic field around it, and so the point of the star near the horseshoe magnet moved. The point of the wheel tipped into the mercury, both below to maintain the circuit while allowing the wheel to move. Fleming's left-hand rule. Fleming's left-hand rule. Fleming's left-hand rule helps us to predict the movement of a current carrying conductor placed in a magnetic field. According to the rule extended the thumbs, forefinger and middle finger of the left hand in such a way that all three are mutually perpendicular to each other. If the forefinger points in the direction of the magnetic field and the middle finger in the direction of the current, then the thumb points the direction of the force. Exerted on the conductor. This rule is named after English electrical engineer John Ambrose Fleming, who came up with it. Suspended coil is a magnetic field. What to do? Press switch A, note the direction of the current flow, observe the deflection of the coil towards one pole of the magnet. Press switch B, note the direction of the current flow and observe the deflection of the coil towards the other pole of the magnet. What is happening? The coil is suspended between the poles of a horseshoe magnet. When current flows through the suspended coil, it behaves like a magnet due to the magnetic field induced in it, and it is attracted by one of the poles of the horseshoe magnet. When the direction of the current in the coil is reversed, it is attracted towards the other pole of the horseshoe magnet. Earth, the great magnet. Earth, the great magnet. Earth acts like great big magnet. It produces a magnetic field which makes compass needles and the magnets point in the direction of its magnetic poles. At the center of the earth is its core. It is made up from iron and nickel and has two parts. The inner core made of solid metal and the outer core made of liquid metal. As the earth spins, the two parts of the core move at different speeds, and it generates the magnetic field around the earth and make the earth seems to have a large magnet inside it. Earth's pole. The earth spins on its axis, which is an imaginary line that runs through the center of the planet. The ends of the lines are called the geographic north and south poles. Their positions on the surface of the earth are fixed. The north magnetic pole originally got its name because of its place to which the north poles of power magnets points. In reality, it's the Earth's south magnetic pole because it attracts the north poles of magnets. Similarly, the south magnet poles is really the Earth's north magnetic pole because it attracts the south pole of the bar magnet. Magnetic north pole is not the same place as the geographic north pole, and it changes position slightly every year. The north magnetic pole is currently situated near Bathurst Island in northern Canada, about 1,600 kilometers from the North Pole. The south magnetic pole is near the Adelaide coast on the continent of Antarctica, about 2,600 kilometers from the South Pole. Both poles positions can wander up to 10 kilometers per year. Antarctica, South Polar Plateau, South Pole. Arctic Oceans, North Pole. North Geographic Pole, South Magnetic Pole. South Geographic Pole, North Magnetic Pole. Earth spins axis. Liquid outer core, mantle. Solid inner core, crust. William Gilbert showed that Earth is a huge magnet with magnetic poles near the geographic north and south poles. He also demonstrated that the compass needles follow the lines of the magnetic force which flow in an arc around the Earth between the magnetic poles. Magnetic field around the conductor. Galvanometer. Leopold Nobili, 1784-1835, devised one of the earliest sensitive electrical measuring instruments, the astalic galvanometer. Galvanometer is used to detect, measure and determine the direction of the small electric currents. It makes use of the deflection of the current carrying coil in a magnetic field for measurements. Tangent galvanometer. Tangent galvanometer is galvanometer in which a small compass is placed horizontally in the center of a large cylindrical coil of wire. The current through the coil is proportional to tangent of the angle of the deflection of the compass needle from its normal position. Tangent galvanometer. Helmholtz type. 1849 refinement was made by Hermann von Helmholtz. 1821-1894 to the tangent galvanometer. He suggested the use of two identical current carrying coils placed parallel to each other to form the arrangement known as Helmholtz coils. If the separation of the coil is equal to their radii, the small compass needle moves in magnetic field which is essentially uniform. Magnetic field around current carrying conductor. Conductor, magnetic field lines. Deflection, direction of magnetic field lines. Right hand. Electric current. Helmholtz tangent galvanometer. Magnetic field around current carrying conductor. What to do? Press switch, note the direction of the current flow and observe the reflection of the compass needles in the direction. Press B, note the direction of the current flow and observe the deflection of the compass needles in the opposite direction. What is happening? When a current is passed through conductor, a magnetic field will produce around the conductor. If compass needles are pivoted around the conductor with the conductor at the center, then the compass needles orient themselves along the field. The current is proportional to the amount of needle deflected from the original position at rest. Faraday's ring. What to do? Press the switch and note the deflection of the needle in the meter. What is happening? The coils are wounded on an iron ring core. One of the coil is connected to a direct current through a switch. The other coil is connected to a meter. When you press the switch, current flows in the first coil. When current starts flowing to the first coil, momentary induced current appears in the second coil. You may notice that the induced current vanishes even if you keep the switch pressed. Similarly, the moment you release the switch, you will observe once again a similar induced current in the second coil. This is because at the time of switching on or off the current in the first coil, there is a changing magnetic field in the ring and core, which is in turn induced a momentary current in the second coil. This effect is known as electromagnetic induction and was first demonstrated by Michael Faraday. Michael Faraday, 1791-1867. Michael Faraday, a British physicist and chemist, is best known for his discoveries of electromagnetic induction and of the laws of electrolysis. His biggest breakthrough in electricity was his invention of electric motor in 1821. In 1831, Michael Faraday made his discovery of electromagnetic induction with an experiment using two coils of wire wound around opposite sides of a ring of soft iron. Michael Faraday, Faraday's ring. First coil, Faraday's ring. Moles, 0. Faraday's motion. What to press switch here, note the direction of the current flow and observe the rotation of the conductor in a clockwise direction. Press B and note the direction of the current flow and observe the deflection of the conductor in the anti-clockwise direction. What is going on? There is a current carrying conductor which can freely rotate around a fixed vertical magnet. The end of the conductor is dipped into a dish of mercury. When current flows through the conductor, it produces a magnetic field around the conductor which interacts with the magnetic field around the magnet, resulting in the rotation of the conductor in forward direction. The reversal of the current in the conductor reverses the rotation of the conductor. Faraday's continuous motion experiment. Faraday's electromagnetic rotation apparatus. Electric current is produced by a continuous movement. A shift wire was suspended from flexible one so that it could move freely. The lower part of the stiff wire was placed near one pole of the permanent magnet. The end of the wire is dipped into a dish of mercury. The mercury allowed the end of the wire to move, and being metal, it also conducted electricity. When current flowed through the wire, magnetic field is produced around it. The field interacted with the magnetic field around the magnet, and the wire began to move around it. Electricity by moving coil. What to do? Rotate the handle and move the coil in and out of the field. Observe the alternating current generated in the ammeter. Rotate the handle faster to generate more current. What is happening? Faraday's experiment can be repeated by moving the coil in and out of the field of magnet. The needle of the meter starts oscillating showing that alternating current is generated. This is the principle behind electric generators. Electric generators. In this position, there is no current flow, but there is a large potential difference, large voltage. In this position, the voltage is 0 and the current flow is maximum. Source of energy. Energy exists in various forms like mechanical, thermal, chemical, electrical, atomic, etc. Most of the energy used on Earth once came from the sun and is now stored in resources such as oil and coal. As Earth's population grows, the demand for energy constantly increases. Before the Earth could run out of energy, it is necessary to harness renewable energy resources which could go on producing power forever. Non-renewable energy. Renewable energy. Coal, nuclear, fossil fuel, oil, energy, the fuel of life, natural gas. Non-renewable energy. Petroleum, natural gas, coal are called non-renewable energy or fossil fuels. Fossil fuels are obtained from the planet's animal remains trapped in rock. Only limited amounts of these fuels are left. Though uranium is not a fossil fuel, but it is extracted and used. It cannot be made again in short period of time. Renewable energy, geothermal energy, solar energy, biomass energy, hydropower energy, wind energy, renewable energy, new energy sources that never run out of called renewable energy sources. Renewable energy sources include solar energy, which comes from the sun, which can be converted into the electricity, wind energy, geothermal energy from the inside the earth, biomass from the planets, biomass from the plants, hydropower and ocean energy from water are all renewable energy resources. Electricity from water power. A dam built in a reservoir, turbine, penstock, generator, transformer, transmission line. The force of moving water is very powerful, and hydroelectric plant uses the force to generate electricity. Hydroelectric plants are built near moving water such as a river, and also man-made facilities such as dams that create moving water. The potential energy of the falling water is converted to magnetic energy as the force of the water turns the turbine. The generator connected to the turbine rotates, converting the mechanical energy to electrical energy. The use of hydropower is economical, helps conserve our fossil fuels, and is a clean, environmental friendly source of energy. ಹೈಡ್ರೋ ಪವರ್ ಟರ್ಬೈನ್ ಇದೆ ನಮಗೆ. ಟರ್ಬೈನ್ ರೊಟೇಟ್ ಮಾಡಿದಾಗ ಇಲ್ಲಿ ಲೈಟ್ ಬರುತ್ತೆ. Generation of electricity by natural gas. Natural gas is a generic term used for the mixture of vapors that results from the decomposition of plant and animal materials. For millions of years, natural gas along with oil and coal is a fossil fuel and is found in underground reservoirs. The primary component of natural gas is methane, the hydrocarbon. Natural gas is the cleanest of all fossil fuels and can be used as fuel in conventional steam boiler generators like other fossil fuels. In homes, natural gas is used for cooking, heating. In some power stations, gas is burnt to produce electricity. Petroleum, natural gas formation. Tiny sea plants and animals died and were buried on the ocean floor. Over time, they were covered by layers of slit and sands. Ocean, 300-400 million years ago. Ocean, 50-100 million years ago. Sand and slit. Plant animal remains. Over millions of years, the remains were buried deeper and deeper. The enormous heat and pressure turned into oil and gas. Sand and silt. Rock. Oil gas deposits. Today we drill down through layers of sand, silt and rock to reach the rock formations that contain oil and gas deposits. How was natural gas formed? Millions of years ago, the remains of plants, animals. Remains of plants, animals decayed, build up thick layers over time. The mud and soil changed to rock, covered the organic materials and trapped it beneath the rock pressures and heated. Changed some of these organic materials into coal, some into oil, petroleum, and some into natural gas. Tiny bubbles of waterless gas. How do we get natural gas? Industrial, commercial, city gate, residential, distribution system, underground storage, transmission system, gas processing plant, compressor station, offshore gas well, onshore gas well. Start. How do we get natural gas? Natural gas can be found either onshore, offshore, deep in the ocean. Once the gas is found, it flows up through the wall to the surface of the ground and into the large pipelines. Some of the gas that are produced along the methane, such as butane, propane, also known as byproducts, are separated and cleaned at a gas processing plant. The byproducts, once removed, are used in a number of ways. For example, propane can be used for cooking on gas grills. The gas is collected in huge storage tanks underground in old gas wells. Natural gas is moved by pipelines from the producing fields to consumers. Because natural gas is colorless, odorless and tasteless, mercaptan, a chemical that sulfur-like odor is added to before distribution to give it a distinct unpleasant odor. Smells like rotten eggs. This serves as a safety device by allowing it to be detected in the atmosphere. In case where leaks occur, natural gas is also being supplied as a liquefied natural gas, LNG. When chilled to a very cold temperature, approximately 260 degrees Fahrenheit, natural gas changes into liquid and can be stored in this form because it takes up only 1/600th of the space that is wood in its gaseous state. Liquefied gas, LNG, can be loaded into the tankers and moved across the country, generating electricity by natural gas. exhaust gas, boiler, condenser, water, steam turbine, generator. First combustion gas turbine generator, combustion chamber, fuel, air, compressor.
And the ticket fee is ₹40 per head. Interested visitors may purchase the tickets from the counter adjacent to 3D theatre. Tickets will be issued on first come first served basis.
Generating electricity by natural gas. Natural gas can run gas turbines. In gas turbines, fuel burning in a high pressure combustion chamber produces hot gas that passes directly through the turbine, which spins a generator to produce electricity. The turbine also spins a compressor to provide high pressure air to the combustion chamber. This cycle is different from the steam turbine, where the heat of the combustion turns water to steam, which pushes the turbine. Gas turbine in the generator in the current. Natural gas, generating electricity by natural gas.
The show will commence in a few minutes in the 3D theatre located in One Science Gallery at
Demand. Energy demand. Energy is recognized as one of the criteria for measuring economic and human resource development of country. In India, the power generation is largely based on the thermal plants using coal or petroleum products. Growth in energy supply has not kept pace with the increasing demand as India continues to face acute energy shortage. Power generation, Indian scenario. In India, power generation is mainly controlled by central government, one public sector undertaking and state level corporation like National Thermal Power Corporation, NTPC, National Hydroelectric Power Corporation, NHPC, Nuclear Power Corporation of India Limited, NPCIL. State-owned corporation like Karnataka Power Corporation Limited is also involved in the generation of and the distribution of electricity. The Power Grid Corporation of India is responsible for the development of national grid and interstate transmission of electricity. As on 29 February 2016, the power generation capacity in India is about 2,80,665 megawatts. Ministry of Power, GOL, powermin.nic.in, power sector, clients, all India. This 201, 2 lakh. Of this 2 lakhs 1,360 megawatts is thermal, about 42,703 megawatts is hydro, and about 5,780 megawatts is nuclear. Another 38,822 megawatts is estimated contribution from renewable sources of energy. Total installed capacity as on 29 February 2016. Sector, state sector, megawatts, 9,79,051. 97,951 megawatts, 33.3%. Central sector, 74,847 megawatts, 25.9%. Private sector, 11 lakh 1,15,868. 1,15,868 megawatts. Percentage 40%. Private sector. Total 2,88,665 megawatts. Installed. Demand is more. Supply is very less. Energy demand in South Asia by 2020. Bhutan, 1,749 gigawatts demand. Supply is only 1,449 gigawatts. Demand is 2,430 gigawatts. Nepal, demand 6,910 gigawatts. Supply is only 3,200 gigawatts. Sri Lanka. Demand is 21,040 gigawatts. Supply is only 10,780 gigawatts. Bangladesh. Demand is 67,400 gigawatts. Supply is only 28,470 gigawatts. Pakistan. Demand is 2,46,000 gigawatts. Supply is only 95,000 gigawatts. India. Demand is 18,45,000 gigawatts. Supply is only 9,37,000 gigawatts. Total demand 21,97,830 gigawatts. Supply is only 10,80,587 gigawatts. Total 2010 and 2020 compound annual growth rate. Demand in India, with a rapid economic development and IT revolution, the demand for reliable quality power is growing steadily. Over the past 4 decades, the demand for energy has grown at an average of 3.6 per annum. As on 20th February 2016, the power generation capacity in India is about 2,88,665 megawatts. And the total number of consumers are over 144 million. India is the world's 6th largest energy consumer, accounting for 3.4% of global energy consumption. Where is 2,88,065 megawatts? And where is 144 million? I got only those. How I got it supply. Supply demand scenario. India's energy consumption has been increasing at a very fast rate due to population growth and economic development. To meet these demands, new generation capacities are to be added. Despite several government initiatives, the power generation capacity in India has continued to be about 12% short of requirements. Future scenario. The future power generation systems have to be environmental friendly. Solar, wind, hydro, biofuels are some of the renewable energy sources identified to meet the future demand. Wind is the largest contributor and is growing very fast. The contribution of solar, photovoltaic and solar thermal technologies also plays an important role. Chemical sources such as fuel cells, especially the hydrogen fuel cells, holds bright promise for the future. Forecast for different sources and energy production in the world. 1,000 terawatt hours. 1990, 2000, 2010, 2020, 2030, 2040, 2050. Coal, natural gas, oil, hydro, nuclear, solar, wind. Wind power, hydro. Direct the air jet towards the turbine and see that the turbine generates electric power to light up the lamps. Try changing the speed of the turbine. What is happening? Wind turbines collect the kinetic energy of the wind and turn a generator to produce electricity. The air jet is directed towards the turbine. It rotates faster and more number of lamps used. When the air jet is moved away from the turbine, it rotates slower and less number of lamps glow. Generally, wind turbines are designed to operate at wind speeds between 15 milliseconds, 54 kilometers per hour to 20 milliseconds, 72 kilometers per hour. The blades rotate at 10 to 22 revolutions per minute. Generation increases with increase in wind speed, but safety mechanism sets off the turbine if the wind speed exceeds 20 milliseconds. Environmental impact of wind power. Environmental impact of wind power. Wind is a clean source of energy. Wind plants produce no air or water pollution. Wind power generates three categories of environmental impacts. Visual impacts, as wind farms are comprised of large numbers of turbines, each mounted atop tall towers in rural areas. They can often be seen for a long distance. Whether this visual impact is good or bad will vary from locations to location. To some, the glistening blades of windmills on the horizon are an eyesore. To others, they are a beautiful alternative to conventional power plants. Noise pollution. Wind turbines, particularly older designs, emit noise that can be heard in the vicinity of the wind farms. The level of noise produced by one wind turbine is equivalent to that of your washing machine. The frequency and volume of this noise can be controlled but not eliminated by wind turbine design. Wildlife impact. The most controversial significant negative environmental impact of early wind turbines is the impact on bird populations, an issue largely resolved by new turbine designs. Generation of electricity by biomass. Press the start switch and observe the process by which biomass is used to generate electricity. Biomass is any organic matter that can be used as an energy source. Organic is anything that is alive or was once alive a short time ago. Organic materials are renewable energy sources like trees, plants, animal waste. Energy is produced by converting biomass like cattle manure into gas, methane. Liquid fuels, by adding heat or chemicals to the biomass, it produces a fuel that can be burnt to run an external combustion engine